Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama-BUENA VISTA Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Hi, we're here live at Panama Elementary, home of the Yellow Jackets, and we are here to...
Yeah!
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott, and we'd like you to be a part of our program if you happen to have a math question. If you're here in Bakersfield, give us a call. The number is 636-4357. Even if you're in San Luis Obispo, you can join our show. The number is toll-free, 866-636-6284. You can even email us your math question. dothemath@kern.org. You can watch the show online, dothemathonline.net, and of course, if you're any part of social media, we have accounts on Facebook, Instagram, Twitter, and YouTube.
You know what? I was thinking about it when you were talking about if you have a math question, but they might be doing science, and if you have a mathematical science question,
Sure. Oh, yeah.
because there's a lot of math involved in science, you might be doing some other topic or subject.
Right.
And if it has something to do where we can help you out, by all means, give us a call. We do have phone tutors available until 5:30. We have a very special guest in the studio. We
do.
We'll meet her in just a few moments. We'll also be going back out to Panama Elementary, and today is election day.
Today's election day, that's right.
And I'll put you on the spot. Did you vote?
I did vote.
All right.
Yep.
Did you go in person or did you do the
I have a mail-in ballot, but my schedule's been a little crazy, so I actually dropped the mail-in ballot off at the polls.
Oh, okay.
But the vote is going to be counted, so I feel good about that.
The vote is in.
Yeah, vote's
We
in.
sent ours in last week, so, but that has to do with today's Math in the News. All right, so today's election day and votes are in and you have to count them. So we have our, I don't know, let's say our mascot for election day, the count.
Mascot.
So I think, I would have to say that probably 90% at least of the viewers looking at the program right now know who the count is.
Yeah, there you go. You got to know who the count is.
I mean, we grew up with the count.
Right.
And as far as I know, Sesame Street is still on.
Yep, still on.
And still has the count, and count counts. Yeah, I mean, that's one thing he does it well. But there are contests. There was an article in a publication about very close contests and elections, and there were some in different parts of the world, but I figured we'd take a look at one in the United States and one close to us,
right,
that were decided by one vote. People go, oh, my vote doesn't matter, it doesn't count. Well, they all count. Sure. And in some cases, they do matter. Right. There was an instance in India where it was decided by one vote, okay? And the person that lost, their driver did not get a chance to go vote, and their spouse.
Oh.
So that was 2 votes.
That would.
And the other person, one of their relatives or something, actually voted in 2 different spots.
Oh.
So somehow that was working, but it was funny that the person that lost, it was like their driver, who, the chauffeur,
right,
and the spouse
didn't vote.
Oh, and that, but anyway, let's take a look at the ones here. 1910 in Buffalo, New York, congressional district. Charles B. Smith snuck by incumbent Alexander by a single vote, over 20,000 votes for this seat.
And it came down to 1.
And it came down to 1, so it was 20,685 to 20,684. United Kingdom parliamentary election was decided by a single vote in 1910. That one, not as many votes, but still it came down to 1. for that seat
Something about
in
1910,
the House
huh?
of Commons.
Close votes in 1910.
That's right. And you know what? I mean, there have been ones in recent days, and it's not like one, but
Right.
they're very, very close.
Sure, that's
And,
right. We had a presidential election that was close within
right.
the last 20 years, right?
So figured, all right, well, that's nice. So there are some numbers in there, and they're decided by one vote. But let's take a look and see exactly why we have the count on there.
Right.
Well, counting numbers are the set of numbers that we use to learn how to count. 1, 2, 3, 4, 5, and so on. They are also called natural numbers. Maybe since they feel natural to us because they are naturally the first numbers we learn. Sometimes they're also referred to as positive integers, and we can see those right there. And that's how we tie math in, even down at kindergarten, to today's topic of voting and the election and our mascot, the count. And that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 on most Tuesdays and Wednesdays throughout the regular school year. And in studio with us right now, we have Kaajal. How are you?
I'm fine.
Why don't you let everybody know where you go to school and what grade you're in?
I go to McAuliffe Elementary and I'm in 6th grade.
How's 6th grade?
It's okay.
It's okay. Have you been at McAuliffe for a long time?
Yeah.
How long?
This is my 5th year.
So you've been there for a pretty long time. If you could change one thing about McAuliffe, because you've been there for a while, what would you like to see different?
They probably add more things to do during recess.
So during recess, all right, so like lunch recess and stuff like that. So some more things to do. So do they have like playground equipment for you guys to do?
They have one.
They have one? All right, so what kinds of, so if they said, you know what, Kaajal, we are going to open up recess and we're going to have more things available for you guys to do at recess. Is there one thing that you would like to see out there more than another, or just one thing that comes to mind?
No.
But you want more things out there? All right, well, here's what you're going to need to do. I'm going to give you an assignment. You and your friends, during the rest of this week, think about what you guys would like to have added to your school during recess time so that there are more options for you, all right?
Okay.
And then what you need to do is, if you want to, you can call us here on Do the Math, let us know what your thoughts are. And then together, we'll approach your principal and see what we can get done. How's that sound?
Okay.
That sounds okay? All right, so during the week, you need to get a hold of your friends and say, listen, we need to think of some things that we want to do during recess instead of just the stuff that we've been doing. Deal?
Okay.
All right. You know why you're here today?
Yeah.
Why?
Because you're going to give me math problems to do.
That's right. Over to the board, young lady.
At least you know why you're here.
That's
good.
right.
Good to know your purpose.
All right, Kaajal, I want you to write down 4 4s and put a little bit of space between them. So write down a 4, leave a little bit of space, put another 4, and do the same thing 2 more times. So that way you'll have 4 4s up there. At the end of it, put an equal sign. And I want you to come up with a number between 0 and, how old are you?
11.
Between 0 and 11, put a number up there after the equal sign. 8. All right, so what I want you to do is you're going to use 4 4s. And in between the 4s, you can put operation symbols like addition, subtraction, multiply, divide, things like that. You could use parentheses. You can use any mathematical symbols you want, okay? And you have to get the 4 4s equal to 8. And if you need some help, Scott's right there. Sound good?
Yeah.
All right, go to it.
Oh, she's going right to it. Oh, whoa, whoa, wow, all right. So 4 minus 4 is 0. Plus 4 is 4. Plus 4 more is 8. That's great. Do it again. What else?
Yeah, hot shot, do it again.
Yeah, that was
Do it
fast.
a different way.
That was so fast, you got to do something different. Nice job. That was really quick. Okay, tell us what you're thinking here. 4 times 4 is 16. Now we got to get back lower again, right? So in order to negate that, what's going to happen here? Oh, went back to divide. Okay, 4 times 4 is 16. Divided by 4 is
4.
4. You're going to add in there.
All right, so leave the
Nice
symbols you
job.
have right there. Underneath that, put the symbols that you did the first time.
Okay.
And we're going to see how many different ways you can get 8.
Oh, that's right. You did the minus first, and then you did plus, and then you did plus. Good.
All right, now, here's what I want, okay? I don't want you doing something like 4 plus 4 minus 4. Because so think of another way that you can get 8 using 4 4s again.
Let's make it creative. Let's be as creative as possible. Think we can get a really, really big number and then bring it all the way back down to 8? What's some other creative ways we can use? Is there any symbol that we haven't used yet? You use addition, subtraction, multiplication, division. Can you think of another math operation that we haven't used yet?
Think about the square root symbol.
Square root. There you go.
Are you familiar with square roots, first of all?
Yeah.
Okay. So
So
think
what
about
would happen
using
if you
that
took the square root
someplace.
of the first one, the 4?
It'd be 2.
Okay, can you show us? There you go. So that's 2. And then what else? How would we get 8? What are you going to do with the rest of it? So this is 2. I'll go ahead and write down what it is right below it. What about the next one? Interesting thoughts, huh? Yeah, if you have to start with 2, what else? You want to do it again? Okay. Oh, there you go. Times 4. So that's 8. And then let's see if we can stay at 8. Let's not move off 8 again. So what could you add to, like let's say I did this. You know you have 8, right? You're okay. You're already where you want to be. What could you add to 8 to stay at 8?
You can
What would you add to 8 to stay at 8 to make sure that number didn't change at all?
0.
0, that's right. So with these last 2 4s, can you make a 0?
Yeah.
Do it. Good, you could do it right inside the circle that I made there. Ah, there you go. Now what would have to happen if you had this and this, okay? What would have to happen in this problem if you were doing this to make sure that you got 8?
You'd have to add all of them and see what you got.
You could, yeah. I want to make sure that the order of operations is what I'm thinking. Make sure the order of operations is correct. So if you look at this problem, you have a square root sign, you have a multiplication sign, addition and subtraction. Which part would you do first?
This one.
Square root, good. So we did that part. What part would you do next?
This part.
Would you do that one next? That'd be good to know, huh? So if you wanted to make sure that was a 0, we'd want to put some parentheses around there, right? And then the multiplication, and then the addition. So lots of different ways to do 8. You picked a good number to have lots of options.
There you go. Nicely done. 636-4357 is the phone number. We do have phone tutors available until 5:30. Don't forget, phone number is toll free, especially for the folks in San Luis Obispo County at 1-866-636-6284. We're going to have Kaajal do some more problems, but right now we have an opportunity to go out to Panama and visit with April.
Stand by.
Hi, Mike. We're here live at Panama Elementary, home of the Yellow Jackets, and I am here with Serenity. Serenity, what grade are you in?
4th grade.
4th grade. What do you like about Panama, Serenity? Do you like it because you're a Yellow Jacket? What is a Yellow Jacket?
It's like a bee.
It's like a bee. Well, you look like a busy bee, so let's do some math here. We're going to multiply with regrouping, and I'm going to give you the pen and let you do the driving. So if I have here, our example says 83 times 77. I want to know, let's estimate first to see approximately where might our product be. Okay, so if I'm estimating, talk me through estimating. What should I do?
You should round 83 down to 80
So why am I rounding down?
because it's not higher than 5.
What's not higher than 5?
The 3.
This is not higher than 5, and 83 is closer to 80 than it is to 90, right? So let's go ahead and write that there. So I'm going to round 83 to 80. And then what about 77? That rounds to 80. And that rounds to 80 because 77 is closer to...
Closer to, it's closer to 80 than 0.
or than 70. It's closer to 80, definitely closer to 80 than 0, but it's also closer to 80 than it is to 70. So we can write that there. And if I look at the ones place, 7 in the ones place is greater than 5, so I know to round up to the next 10. And so if I estimate, I'm going to multiply. How are we going to go about this?
You're going to multiply 8 times 8, which is 64.
Okay,
And then you're going to add your 2 zeros.
2 zeros. So this gives us the estimate. Whatever our answer will be somewhere near that. It could be lower or higher, correct? Okay, so let's find the exact answer. Talk me through that. So how would I go about multiplying 83 times 77?
First, you would multiply 7 times 3,
Okay,
which is 21. Then you'd put the 2 there, the 1 down here.
and the 2 goes here because this is in the tens place, right? That's the place value. Go ahead.
And then 8 times 7 equals, I think it's 56.
I think so too.
And then you would add your 2, which is 58.
Okay,
So you would put the 58.
okay.
And then you would X out the 7 because you already used it.
I used the 7. So how do I show that I've used the 7 in another place? So I've used the 7.
You would also cross it out there.
Okay, now go ahead. I saw you ready to cross out that too because we've already used this, we've used this. And do you know why we put an X right here?
I thought it was because the 7 is,
In what place value? What place value is this? The 7 is in the... Do you know what place value this is? This is the ones place. So the 7's in the ones place. We already took care of that. So we have to put an X here in the ones place because there's nothing to do there in the ones place. Okay, go. Let's multiply the 7 in the tens place.
7 times 3 also equals 21, so we put the 2 back there. We put our 1 right there. 8 times 7 equals 56, and add a 2 again,
Okay.
which is 58.
And then I'm going to
Add it.
add straight down.
1, we would do the X as a 0, so that's going to equal 1, and then 8 plus 1 equals 9. 8 plus 5 equals 13.
Okay, 3 and carry. Oh, go ahead. You you like to write the top number first. Okay, makes sense. Comes first.
5 plus 1 equals 6.
And 6,391 is very close to 6,400. Great job, Serenity. Can you smile at the camera? Back to you in the studio.
All right, nice work out there at Panama Elementary with Serenity and April. Hey, we do have phone tutors available until 5:30. We have a 6th grade student from McAuliffe, Kaajal, in studio with us right now. And time for you to get busy on another problem. So here we go. This one is out of a book made especially for you. So, write and solve an equation to find your average speed, S, on a plane flight. You flew 525 miles in 1.75 hours. So what do you know about these types of problems?
You multiply rate times time to get distance.
All right, why don't you head on over to the board. You and Scott are going to work on this. So you said that distance is equal to rate times time? Okay. So you're going to use that information, and we'll go ahead and take a look at the problem again, and then you can go ahead and figure this out. So you flew 525 miles. So where's that going to go?
Grab your pen there, Kaajal. So where do things go? Okay, the 525. What is it? 525 what? Miles? Okay. Miles for distance. Good.
And it took 1.75 hours.
Good. We're going to still keep that equal sign in there. Is that all right? We're missing something here. Missing that one. All right, what do you want to do here? How are we going to figure out what that rate is? Tell us a little bit about what you're doing there. 525, and you're using the 1.75. What are you going to do with those?
You divide 525 by 1.7.
Good. Why are you dividing?
Because if rate times time equals distance, then rate equals distance divided by time.
Okay, I like what you said there. So while you're working there, I'm going to write down what you said. Rate equals, rate equals distance divided by time. Okay? So when you do this division here, you took the top equation that we have there and made it into this one here. When you do this division, what's the first thing you're going to do if you're dividing that number there? Move the decimal. Gotcha. So where's the decimal on 525? I don't even see it. If you don't see it, it's at the end. Adding a couple zeros. Good. Okay, so where's the decimal now on the number that's inside the division bar there?
It's over here.
That's where it is outside. That's right. So and you know that because where is it inside?
Right here.
Gotcha. Good. Right at the end. Okay. Good. So what are we going to do first? Tell us a little bit about what you're thinking there. 175 times, like what are you looking for?
I want to see what 175 times what equals 525.
Okay, times what? We like to get as close as possible without going over, right? So what's your first thought there?
7.
A 7, okay. Maybe a 7 will work. And that's a really good guess too. I like what you thought about there because 5 times 7 is 35. It ends in a 5. We'd like that one to end in a 5 as well. If you multiply it times an even number, it would end in a 0, and that wouldn't be what we're looking for. All right, let's see what you get. So 7 times 7 is 49, plus 3 more, little plus sign in there. Plus 3 more is 52, right? So you put the 2 down and carry the 5. Pretty big, huh? Yeah, not going to quite work. That's all right. Try another one next to it. So you know it's not going to be quite that big. 175. Can you do a little bit of estimation and think about it in your head? What is, I'll write it over here. I know it's not being written very well over there. What's 175 times 2? What's that going to be close to? Can you think about what that might be?
Well, somewhere around 300.
About 300, yeah. 300, 400, somewhere in there, right? What about 175 times 3? Can you think about what that might be close to? If this was close to 300, what do you think 175 times 3 is going to be close to?
500.
500. Let's give that one a try. That might be a good educated guess to do because you know it's going to end in a 5 because 5 times 3 is 15. That's good, okay? So why don't you work that one out, see what you can do, and see if we get close to a 525. Hopefully right on it, which would be nice. 5 times 3 is 15, carried the 1. That was good. 3 times 7 is 21, plus 1 more, right? Tell us what's going on in your head here. We'd like to hear what's happening. 3 times 7, 21, plus 1 more, 22. You carried the 2, so what's this last step here? 5. Where'd the 5 come from?
1 times 3 is 3, and then you add the 2
And then
and
you
you
add the 2 in there. Good, so you found what you're looking for. All right, so where does the 3 go then?
Right on top of this 5.
That's it. I'm really glad that you put it over top of the 5 as well. That's really important because it's not going into 5. We're not going into 52. We're going into 525. Good job. And you already know what the result is. 0. All right, so the answer is 3, right?
No,
No. How come?
because then you have to add down these zeros.
Have you ever seen one of your friends do that before? Forget about those zeros? I've seen lots of students do that in the past. When you move your decimal over, which was a wonderful thing to do, and all you're going to do when you bring down the 0 is a 0. Oh, okay, well, sometimes you can drop a 0 in a number, right? Like especially after a decimal. But in this case, you can't drop those zeros, huh? So how many times does 175 go into 0? 0. All right, so the answer is 30. No, there's more. Tell me more. What's going on there? Oh, there's one more 0.
Drop down the other 0, and
Yeah.
then it's still 0.
Gotcha. Still 0. So there's not a lot of math to do, but those zeros are really important, right? That makes the difference between 3 and 30 and 300. And I don't know about you, but I'd rather have $300 than $3, right? So that's a big deal. Okay, so we have 300, but in the original problem you had 525 miles. That was a certain amount of units, right? And here we have 1.75 hours. What kind of units are you going to use for the rate?
300 miles per hour.
300, we got that part here. And going back over to here, right? This was miles, and the time was hours. And that's something that we all kind of have heard about, right? Miles per hour. So how would you write that after 300? What would be your abbreviation for it? Good, miles/hours. You've also maybe seen this, right? MPH, miles per hour. So you can do that as well. Really good math. Nice job there.
Nicely done. So leave the formula up there,
Okay.
and you get rid of the rest, or you just get rid of it all and put the abbreviation up there, D equals RT.
Okay.
So we'll give you another one, but you're going to look for something different this time, okay?
Distance equals rate
So
times
this time you flew 1,530 miles
I'll do that part. 1,530 miles.
at a speed of 340 miles per hour.
340 mph.
And now, Kaajal, if you could
What's the
find
question?
the missing piece.
Yeah, you know what the question is. What is the question, even without it being read to us? What is that question?
It's asking you what the time is.
That's
Correct.
right. And what do you think the time is going to be measured in?
Probably hours.
Probably hours, yeah, because we have this whole miles per hour thing, right? So we'll go ahead and put that there. So when we're done with this, then we know at least what the units are going to be. All right, so where are you going to start with this one?
I'm going to divide 153 by 340.
Okay, sounds good. You want to set that up? Good. Okay, where do you want to start? You ever seen a division problem written as a fraction?
Yeah.
1530 divided by 340. Now, if you saw that fraction, what you've written is absolutely correct. Please don't think that it's wrong at all. But if you saw this fraction, is there any way that you can make, you can start this problem and make things a little bit simpler?
You could probably just simplify it.
You could simplify it, yeah. You could do some reducing first, right? And you still get the same answer, just the numbers would be smaller. So we could do that, but nothing wrong with what you're doing here. Let's go ahead and give that a try, see what's happening. What's going to be close? Let's see. 340 times 2, what's that going to be close to?
That's going to be 680.
Okay, 680, so that's not quite where we want to be. So if you double that, it'd be 340 times 4. What's 680 plus 680?
13,000.
Yeah, 13, pretty close, huh? So we're pretty close to 5. So maybe a 4 would be a good guess. Maybe a 5, we can go that high, maybe. 8 might be a little bit much. We don't know for sure. Let's see if we can use the back end of our pen. We'll try it a little different here. Sometimes it works, sometimes it doesn't. What do you think as an educated guess that we want to use for that bottom number there? What are we going to multiply by?
Probably like a 4.
Yeah, let's give it a
5,
try.
6.
Let's give that 4 a try. 4 times 0 is 0, good. 4 times 4. 16, carry the 1, good. I'll be your narrator today. Hey, we're awfully close. Okay, let's give it a try. Put 1360 down underneath here, and we'll see if the remainder hopefully is less than 340, and then we can go from there. Good. You put the 4 over top of the 0, which I think is a really good idea. 0 minus 0, good. And you borrow it over there from the 5. That's a good idea. Oh, hold on. This 5 is going down, right? Because we're borrowing from it. So what's this number? Instead of a 4, or instead of a 6?
It's a 4.
Going to be a 4. I kind of gave it away, huh? Sometimes it erases, sometimes it doesn't. Kind of like those old pencils sometimes, huh? They have good, some of them good erasers, some of them don't. Well, at least we know that we were awfully close. So if we haven't quite gotten to where we need to go, what's next? What do we do with the rest of this problem?
You can pull down
Ah,
a
there
0.
comes that 0 again, like we had in that last problem, right? Okay, so we had 340 times 4 was 1360. So we know we're probably going to have to go bigger than 4, right, to get to 1700? What's your next best guess?
A 6.
Could be a 6. Now think about if you put a 6 here, 6 times 0, that would end in 0. That's good, right? But if you had a 5 or a 4 or a 7 or any number would end in 0. So we don't have quite as many hints this time as we did last time. You want to try a 6 off to the side here? 340 times 6? $24, carry a 2, good. And a 20, yeah, a little bit too high, huh? So we know that 4 is too small. We know that 6 is too big.
That's 5.
Gotta be a 5, no doubt. Prove it. You're okay, no problem. We can keep on going. 340 times 5. That's supposed to be a times. Good. Oh, we got a couple zeros, that's a good thing. And 5 times 3 is 15 plus 2 more? 17. It worked. Good. So, can you finish up the division problem here, and then we'll make sure that we know exactly what the 4.5 means. There you go. Good. Okay, so where's the 4.5 is all we have left here. This is all some extra work that we had for that problem down there. We're going to put 4.5 here. Remind us again what the 4.5 means.
4.5 miles.
Is that right?
Hours.
Oh, hours. There you go. Good. Because we had miles over here. We had miles per hour here. We had 4.5 hours. What's one way, without doing it, what's one way we could check to make sure this answer is correct if we had to go back and check it?
You could just multiply those two.
Yeah, you could. You could take 340 times 4.5, and the result should be
1,530.
1,530. That's it. You got it. So you can always check your answer before you finish. Good work.
Nicely done, Kaajal. 2 problems right there. Hey, we have phone tutors available until 5:30 for such wonderful work right there. We are going to be awarding you with a free meal, courtesy of our friends at Grillin' Burger. So congratulations on that. Hey, we'll go out and visit Panama Elementary, and we'll do it right after this. Today we're on the Central Coast. We're at Grover Beach Elementary, home of the Golden Gophers, and we're here to
Do the math!
All right, back with the students at Grover Beach Elementary, and we're talking about using 24 feet of fencing. And we were talking a little bit about some of the dimensions that you could use with 24 feet of fencing, where we could have a 10 by 2, a 6 by 6, and if we had a house as one of the sides, we could do an 8 by 8 here, all right? The difference between perimeter and area, right, because around it is the perimeter, the area inside of it is the area, all right? So here's what I want you guys to do, all right? You have 24 feet of fencing. You cannot use a house to go up against it. This is going to be freestanding out in the middle of a field, all right? So you can't use a property line or anything like that. As creative and clever as that was, we're going to keep all 24 feet of fencing by itself. Everybody good on that? Mm-hmm. All right. I want you to tell me and show me the greatest area that you can make with 24 feet of fencing. Go.
Okay, so what we could do is one thing for 24. So we need to a square would be good.
Yeah,
Try and get a square
is the biggest.
But then so 6 times 6.
So think about different ways you could make it using 24 feet.
We could do like 3. Top for 3. I'm gonna do it lightly in case we have to.
And then rectangle.
3 for the top.
All right, so make other shapes, see what the perimeters are, and then calculate the areas.
So the 10 times 2, that's 20. That's only 20. So right now, the 6 would be best, and then.
And then we could add plus 4. Plus 4 to make it an even number.
Yeah, and then we could do plus 4 again.
Yeah.
All right, you guys have all had an opportunity to take a look at some of the different shapes that you've made?
Yeah.
All right, let's start here. What was one of the shapes you came up with?
We didn't come up with one yet. We were still working it out.
Still working it out? That's fine. What about you guys? What kinds of things did you come up with?
Well, I came up with a complete fan.
Well, you're still working on it, right?
Well, I worked on this, and then I added up the perimeter to see if it...
Oh, you got a little bit under 24, huh? There you go. I like how you're using decimals, though, to see if you could maximize that area. What did you come up with?
was with the square with the 6 feet and the 4 feet.
Okay. So if you did 6 by 4, right? So you can put a 6 there and a 4 there. So now add them up. So 6 and 4, hey, there you go. Because what you were doing is you were looking 6 by 4, thinking it was 24. But remember, you have to make the perimeter 24 first before you do the area. And what about you guys? What did you guys come up with?
Well, we looked at the rectangle and the square already on the board.
Yeah, start with those, right?
2 is only 20, so that's only an area of 20. But 6 times 6, that's 36, which we think is probably the biggest you could get.
So this, you said 10 by 2 is 20, right? And then here's another one you can think of. Because we can make it a little bit longer than 10, we can go 11. So if each of these sides is 11, what must the ends be?
1.
1. Right? Now what's an 11 by 1?
11.
11 square feet, right? And we don't want 11, right? That's less than the 20, even though somebody goes, oh wow, yours is 11 feet long. But in reality, the area shrinks, right? So you're on the right track, because as the numbers get closer together, because 11 and 1 far apart, low area. Get closer, 10 and 2, there's a difference of only 8 instead of 10, the area gets bigger. When you finally make a square, a 6 by 6, and you hit it right on the button, that is when you get the largest area, and the area is?
36
36.
square feet.
There you go, 36 square feet. Nicely done. You guys have a good time with that challenge?
Yeah, we just keep
There you go.
them at the line.
You just got another one?
Yeah.
A 9 by 3? Yeah. Very good. That is another one. And when you calculate 9 times 3, what do you get?
24 square feet.
Almost. Instead of 24, it's 27, 9 times 3, right? But you see, 27 is more than this because you got closer together, right? So the closer you get together in both measurements, the greater area you have. And that, just a little bit of math with the students from Grover Beach Elementary. And a lovely campus over there. Thanks again to Mr. Snyder and the students. And just a reminder for the students that are watching over there is a contest going on, and it will go on throughout the rest of this month until early December. And then we're going to have to figure out what school called in the most times, and then the students that phoned in the most, and that contest is still up for either one of those schools. We do have phone tutors available until 5:30. We're going to give Kaajal a break right now because we're going to go back out live to April and Panama Elementary.
Hi, we're still here in Yellow Jacket Nation at Panama Elementary. I'm here with Johnny. Johnny, what grade are you in?
4th grade.
4th grade. Johnny, what do you like about Panama?
Getting early out on Wednesdays.
Early out Wednesdays. What? So where did I tell you I taught? Do you remember?
Taught at junior high at Stone Creek.
Stone Creek. Are you going to Stone Creek?
No.
Oh, I'm going to miss you when you get in the 7th grade. So sad about it. So Johnny and I, actually Serenity and I, we multiply by regrouping. Johnny and I are going to do something different. We've got a word problem here, so Johnny and I are going to multiply with distributive property, yeah? Okay, so let's talk about this. The art teacher has 48 boxes of crayons. There are 64 crayons in each box. How many crayons does the teacher have? So how do we figure that out, Johnny? What are you thinking?
You're gonna use that to multiply this because it has 48 boxes and 64 crayons in each box.
So if I have 48 boxes and there's 64 things in each box, I could add 64 or 48 times.
Yeah.
That might take us forever, right? So instead, we multiply. Multiplication is repeated addition. Okay, so go ahead and write the numbers there for me. So we've got 64 crayons in 48 boxes. Okay, draw a line. How do I know I'm multiplying? There you go. But we're going to multiply with the distributive property.
Yeah.
What's that going to look like?
60 times 40 and 40 times 8.
Okay, hold on just a second. Can you walk me through let's do one thing the same. Let's estimate.
Okay.
Estimate our product so we have an approximation of where we might be. So let's estimate really quickly. So 64 is going to
60.
round to 60 because
Anything lower under 4 is
under
5.
yes.
Is
So in the ones place, if it's 5 or less, then we
letter S.
okay.
5 or higher, add one more, I think.
Okay. So 48 is
50.
50 because 48 is actually closer to 50 than it is to 40, correct? Okay, go ahead and multiply. Let's estimate.
6 times 5 is 30, and I have these 2 zeros.
Okay, so that's like powers. And so there's approximately 3,000 crayons, right? Okay, so let's multiply more exact and let's use the distributive property. So how do I do that? What's that gonna look like?
There's 60 times 4 and then 40 times.
Okay, so let's go 60 times
4.
4 or 40?
4.
Let's go 60 times 8.
Okay.
Let's do 60 times 8. Okay, put parentheses around that. And then to that we're gonna add
4, 8 times.
8 times 4. Put parentheses around that. And then we're going to multiply 4 times 60. So let's write that. Put parentheses around that. Oh, I'm sorry. That's not 4. Let's erase that. That's 40. Because this 4 is in the tens place. So 40 times 60.
60?
60. Into parentheses. Plus 40 times 4. Okay, so we've got 8 times 60 here, and then 8 times 4, and then we've got the 40 times the 60, and then the 40 times the 4. So you have parentheses around that? Okay, what's 8 times 60?
48.
48.
You add your 0 back.
Okay, plus
Plus
8 times 4,
32.
plus
40.
plus
Huh? Oh, yeah.
40 times 60.
20.
Thank you, plus plus. All right, so can I write really quickly? So I'm going to stack those. So if I have 2,400 plus 480 plus 160 plus 32, can you add those for me?
0 plus 0 plus 0 is 2. 8 plus 6 is 14 plus 3 is 17. 4 plus 4 is 8 plus 2 is 10. 2 plus 1 is 3.
So was your estimate correct?
Yeah.
There are exactly 3,072 crayons in the crayon box. Great job. Back to you in the studio. And he's gone.
All right.
Feel the excitement.
Here we go.
Grab the pen.
So you're going to want to start way over on the left because this is going to be a lengthy problem. Okay? Write down the fraction 1/2, open parentheses, 16 minus 6x, close parentheses, equals 15 minus 1/3, open parentheses, 9 plus 15x. Now I know that you are familiar with doing equations and solving for a variable, but I just wanted to give you this one with a little twist in it with the fractions. You ready?
No.
Explain to Scott how you're going to do this problem.
So what do you think? What's the first thing we should do here?
Multiply.
Okay, tell me a little bit about that. What are you going to multiply?
1/2 times 16.
Oh, good job. So it's just like a regular distributed property problem, right? We're going to multiply that. So what's half of 16?
8.
8. There you go. I'll write this line for you. What about this? What's half of negative 6x?
Negative 3x.
Good job. Negative 3x. Okay. What about those parentheses? Do we need to keep them in there somewhere?
No.
Okay, all gone. All right. So I did the left-hand side. Let's see you do the right-hand side. What about that 15? What are you going to do with that one?
You're probably going to find out what 15 minus 1/3 is.
You could do that. However, it's not quite what we're looking for because in the order of operations, what's the first thing you need to do in a math expression?
Parentheses.
That's it. You got it. And that we're going to do some multiplication here, right? So let me do this just to make sure that we don't forget. The 15 is going to stay right there. But we're going to do the distributive property like you did earlier here, right? But now you have a 1/3. Tell me about the 1/3. What's the sign on it?
Negative.
It is. So when you distribute that, make sure you distribute that negative. Okay, I'll go ahead and circle that whole thing for you so you don't forget. Okay, now you get to do this part. So your first job is negative 1/3 times 9.
Minus 3.
Good. And negative 1/3 times positive 15x. Wonderful. Boy, wouldn't you rather solve this equation than this whole crazy thing? That's kind of nice, huh? That's, all the parentheses have gone away and all the fractions have gone away. Okay, what's next? Sure, you can do that. Yeah, -8. Sounds good. They'll go away there. Now, usually when I do an equation, I put a line here so I know that if you do it to one side, you have to do it to the other side. All right, where are you going to put that 8? Okay, sounds good. -8. All right, let me give you a little bit more room here. Hold on. Good, so 15 minus 8 is 7. This part is gone, and you have a negative 3x left over here. What's left on the right-hand side?
7 minus 3 minus 5x.
There you go. You want to put the 7 and the 3 together first?
Is 4.
Okay, so 7 minus 3 is 4. You got that part. And what else?
Minus the 5x.
Minus 5x. Good. Oh, you're doing wonderfully well. Things are getting smaller and smaller. We're getting closer to the solution. What's next?
Phone call does not go in the drawing.
You move some numbers together, right? That was a great idea. You put this number, you got rid of it here, and you subtracted it over there. Wouldn't it be nice to put those x's together?
Yeah.
Yeah, let's go ahead and combine the x's. How do you want to do that?
Well, they're both negative numbers.
They are both negative numbers, that's true.
So it'd be negative 8x squared.
Hold on, let's think about this now. You did -8 over here because, right, this was a positive 8. So you did the opposite, which was -8. So how about this? This says -5. What should you do instead? What's the opposite of that?
Add 5.
That's right. So you do plus 5x here, right? And that goes away. It's exactly what we want to happen. Tell me what's left on the right-hand side over here.
It's just the 4.
Just the 4, that's it. But if you do it on one side, you have to do it on the other side too, right? So we did plus 5x. We're going to do the same thing over here, plus 5x. Can you tell me what negative 3x plus 5x is?
Positive 2x.
Good. Go ahead and write that down. I'm really glad you wrote that negative sign, or that positive sign as well. That's good. Good. All right, one last step. Let me give you a little more room. What's the last step?
You divide it by 2
That's
so
it.
you can get x.
Good for you. X equals 2. Is it a positive 2 or a negative 2? It is a positive, that's right. Now, if you had to, how would you check it?
You just put the 2 where all the x's were.
Way back at the top, right? Way back at the top. You
And
can
we're
put
going to
the
have
2 right
Kaajal
here,
do that
put it right there.
over here on the side just to make sure that that is done correctly, because right now we're going to go to the phones, and a student from McKee Middle School, Beyond, how are you this afternoon?
Good.
Did I say your name correctly? Beyond?
Yes.
Okay. As soon as you're ready, let's hear the math problem that you're working on.
4b.
All right, so Kaajal, come on over here. We'll rewrite that problem over here so that way Scott can use the board.
4b, is that what I heard you say?
4b plus 7b.
4b
Yes.
plus 7b. What else do you have?
Plus 5.
Plus 5, okay. So 4b plus 7b plus 5. Is there anything else to this problem?
No, that's it.
Okay, so what are the instructions? What are we supposed to do with this?
Identify the terms,
Okay.
like terms, coefficients, and constants.
Oh, wow. So we have lots of things. So we have terms, we have like terms, we have coefficients, and we have constants. Wow, all right. Okay, what do you think? Can you tell me how many terms are in this expression?
3.
3 terms. What are they?
4b, 7b,
4b.
and 5.
Give me a sign on the 4b. Is that a positive or negative?
Positive.
Good, so we'll keep that a positive. There's also a positive 7b. I heard you say that. What's the last term?
5.
Positive 5. Exactly. And when you're listing those terms, it's a really good idea to put that sign in front of there. All right, what about like terms? What does like terms mean? What's that all about?
The same.
Ah, okay, the same. So I don't see any numbers that are the same here. So do we have any like terms at all?
4B and 7B?
Okay, so it's not necessarily the number, it's the fact that these two terms have the same letter in them, right? So we have positive 4B and positive 7B. Those are two like terms. Coefficients, give us a definition of that. What is a coefficient?
Coefficient is the letter and the number and letter.
Gotcha, the number before the letter, right?
Yes.
The number before the letter. So what are our coefficients in these individual terms?
4,
4,
7,
7,
and 5.
gotcha. Now tell me about 5 a little bit. Does 5 have a letter in it?
No.
Doesn't, right? So we want to look for it. When you're talking about coefficients, you're talking about numbers before letters. So we could definitely, again, put a positive 4, put a positive 7, but that 5 has its own category. And the reason I'm saying that is because we know if there's one more category, you probably can't read my handwriting there. Maybe I should go to medical school because you can't quite read the word there. But it's supposed to say constant, and that's our last category. Which number is the constant?
5.
5, that's it. And we're going to go ahead and put a positive 5 there as well. So just make sure that in that 5 part you don't confuse with the coefficients because it's a constant. It doesn't change at all. It doesn't have a variable next to it. Great job on that problem.
Thank you.
Thanks for that call, Beyond. And for a wonderful call like that, you've got yourself a free meal courtesy of our friends at Chick-fil-A. Hey, we do have phone tutors available until 5:30 on most Tuesdays and Wednesdays throughout the regular school year. Don't forget, if you email us, that email is dothemath@kern.org. Good idea to email us on Mondays, Tuesdays, or Wednesdays. If you email us on a Thursday, we are probably going to get an opportunity to look at it, but not guaranteed. If you do it on a Monday, Tuesday, or Wednesday, it's going to be a little bit easier for us to take a look at that problem, send it back to you, solved, and then possibly even have you take a look at it while we do it on air live. You ready to do another problem?
Yeah.
Oh, good. Well, you're going to have to hold on a second because we have April out at Panama Elementary, and she has another student out there ready to work on a math problem. And take it away, April.
Hi, Mike and Scott. I am still here at Panama. I have a new yellow jacket with me. I have Maddie. What are you supposed to say, Maddie?
Hi, Mr. Kushine.
So how do you know Mr. Kushine? You go to...
I go to GATE in 4th grade, and he's the 6th grade GATE teacher.
Very cool. So earlier we multiplied by regrouping. We also multiplied by this distributive property. And Maddie's going to help us multiply in a different format.
Area model.
Area model. So let's talk about this, Maddie. Can you estimate for me first, though?
Yes.
Okay, so if I have 23, uh-oh, I wrote that a little too high for you, didn't
It's
I?
all right.
Okay. So 23 will estimate...
20 because my 3rd grade teacher taught me this. Find the place up next door, 5 or more, we raise the score, 4 or less, we let it rest. Look to the right, put zeros in sight.
Very nice. That was a cute song.
Yeah.
All right, so
So it's 20.
it's
And
20.
then this one is 30 because it's closer to 30.
Because 25 is closer to 30. Very nice. So I'm going to multiply.
0 times 0 is 0. And then 2 times 3 is 60. So that is our estimate.
Wait, hold on. Okay, so 2 times 3 is 6, correct? And then I have this 0, but what about this 0? Did you do 600? So it's roughly 600. Okay, so we'll be around there. So show me an area model. If I'm going to use an area model, what does that look like?
So it would be like a rectangle since it's not the same number.
Okay,
And then, but it's going to be almost like a box.
okay.
The smaller number would go in the smaller side. Oh, that side. 20, and then 3 down here.
So we're going to take 23 and we're going to separate it because
Yes.
23 is 20 plus 3.
Yes.
And then we're going to go.
20 up
20.
here, and then 5 over here.
So 25 is 20 plus 5, so that's
Yes.
where those numbers are coming from. Very nice.
And then you would draw a line that's about how much 5 would be.
Okay.
And then this is how much 3 would be.
And this is about 20 on
Yeah.
each side. Very nice.
And then so 20 times 20 would equal 400.
So in this square, it's
you
like the
would have
area.
to
I'm going to
do
find the area of
400.
this section. Very nice.
And then 5 times 20 equals 100.
So I've got 5, and then this is 20. 5 times 20 is 100
Yeah.
of that area.
And then 20 times 3 equals 60.
So this is 20, this is 3, this area is 60. Very nice.
And then these two, 5 times 3 would be 15.
Okay, and that's the area of that rectangle.
And then we add it all up. So 5, 7, 5. 575.
And is 575 near 600?
Yes.
Well, then that was a good estimate. We are very, very close, slightly under. Okay, so let's multiply exactly this time. So let's use the green pen.
Okay.
All right, so let's multiply exactly. Let's check our answer to see if we are correct. Is it okay if I erase your little
yeah.
symbols here?
Yeah.
Okay, so how do I, tell me what you're doing as you're doing it.
So, a trick Ms. Schaefer taught us would be to cover up the one we're not using
Okay,
currently.
so I'll hold that covered for you.
So,
There you go.
so 3 times 5 equals 15. So put down the 5, carry the 1, and then 2 times 5 equals 10 plus 1 equals 11. But Ms. Schaefer taught us to always put a 0
Okay,
beforehand.
and so I'm gonna
And
have a hard time
then-
covering up this
It's
5. Is that
alright.
okay?
Yeah,
Okay.
I can use it. And then 3 times 2 is 6.
Uh-huh.
So we will put the 6 down there. And then we're not using that, so get out. And then 2 times 2 equals 4.
And let's add straight down
And
really
then
quickly.
we just add that into 575.
Very nice. Look at there. We've got options. You want to say goodbye?
Bye,
Back to
Mr.
you in this
Kincaid.
studio. Good job.
All right, nicely done. Thanks for that out there, April. You know what? Keep all those kids handy, April, because right now we have Kaajal ready to do one final duty. I was going to give you a difficult math problem, but I'm just going to have you do something else instead. Are you all right with that?
Yeah.
All right. Inside here are the names of the students out of Panama Elementary. And you're going to draw one of the names out, and one of those students is going to win 2 passes to any CSUB athletics event of their choice. All right? So go ahead, reach in there, pull out one of the names. And then
Kaajal,
as
do you
soon as
remember how
get
many
it-
students there were out there?
No.
There were 3. So what's the chances of each one of them you're going to pull here? 1 out of 3. That's it. Each
All right,
of them has
let's
1
go.
chance. Let's see. A little bit better chances than the lottery.
All right. So whose name is that?
Serenity?
There you go. So Serenity, 4th grade student out at Panama. Congratulations. There's our lucky winner of 2 passes to any CSUB athletics event of their choice. So congratulations on that. Kaajal, thank you for coming in and doing a little bit of math with us today. You now are the proud owner of your very first uniform, I think.
Second.
Second uniform? What was your other uniform?
It's the same one I got last year.
Oh, that's so this is the new and updated one. Does it look the same?
Yes.
Kind of. Well, it is kind of the same, but you know what? It's a new one this year. But
Okay.
all you have to do is continue what you have done, because I know you have told people about Do the Math in the past, right?
Yeah.
And see, so you stood by your word, right? So I need you to do the same thing. Tell some others about Do the Math. You can do that?
Yeah.
All right, sounds good. You can still be an ambassador. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama-Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.